All right, let's get started. So a rotation. Um, Yesterday we talked about reflections, and a reflection was something where you needed a line of reflection so you could figure out how far the figure was from that line and then reflect it over the same distance the other side. With rotations, we don't use lines anymore. We use a point. Okay, think about like a spinner on a board game. Okay, when you spin it, there's always a center of rotation in the middle of that spinner, right? Might be like a little brad or something down through the middle of it that holds it in place while it goes around that. Okay, so what we're going to do then is we're going to identify some kind of a figure we want to rotate, and then identify where the point of rotation is, and then use that to take that figure and, based on a certain number of degrees we want to rotate it, move that and then plot it where it needs to go in its new location. Okay, so here's how we do it. So rotation, so using a point of rotation, we will turn an object a certain number of degrees and we can do clockwise rotations and counterclockwise. Okay, so that's pretty much it. And like the other sections, we're going to stick with the coordinate plane. And to further simplify things for you guys, the center of rotation will always be 0, 0, the origin. Okay? So, and we're going to look at just rotations of like 90 degrees, 180 degrees, ones that aren't crazy so that you can more easily see where the thing has been rotated to. Okay? So, we're going to first start by doing a rotation manually, which means you're going to use your protractors to do all the measuring of the angles and everything. But you're going to find there's a shortcut. After we've done the first one, we can kind of take a look at what the shortcut would be. And then from there on out, we can just use that shortcut to help us get through it. Okay? So give yourself a good amount of room here so you can use your protractor to do it. So I'm going to use up like the whole page here.
Whole page?
Well, not that big, I guess, but pretty big, though.
How many?
At least 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, probably 10 in every direction would be good. You guys enough room where your protractor will fit on the page so you can actually use it effectively. So I think that's probably good enough. Yeah, my x-axis is a little long here, but it's all good. So yeah, I'm taking up a good portion of the page here. All right, I'll back that up just a little bit so you can see it better. All right, and so we'll start with, we'll do a triangle. Take this triangle here. Alright, just color ABC there. Say what? Negative 7, 8. Yeah. All right, and so what we're going to do with this one, we are going to attempt to rotate this triangle 90 degrees clockwise. Okay? So we're going to need to use some little construction lines, kind of like we did with the reflections. We're going to take each one of these points, and we're not going to move them. We're not going to like count how far away they are from a line. That's doing the reflection thing. But we're going to connect them all to the point of rotation. So that point of rotation, like I said, is the origin for all of these. Okay. So let's do some dotted lines. So each one of those points do a dotted line to the origin. And you can use your the straight edge part of your protractor, because the more nice and straight we can make these, the better it's going to be when we're done. Okay, so it looks something kind of like that. Now what I'm going to do, just so it's easier for you to see, I'm going to use some of my gel pens, put some color on this thing. Because sometimes you can get kind of lost in what line is where and that kind of a thing. So I'm hoping this will help clarify some of that. But you guys just stick with your dotted lines and that's fine. But I'm going to go over mine with some color. All right, now this line right here. Okay. If I can take that line segment and rotate it 90 degrees, the end of that line segment should be where the new point B should be. Does that make sense? Just take that line segment, rotate it, and wherever the end of it ends up, because the one point is going to stay here, and the other end, the point B, is going to swing around 90 degrees, and wherever that thing ends up, that's going to be the new coordinates for B. Okay? So using a protractor, we need to figure out where that 90 degree mark would be. Okay, so I'm going to take my protractor, line up at the origin, the bottom of it, make sure I'm flush with that line, and then 90 degrees is going to be up here. Okay, so put a little dot above the 90 degrees here, and then I'm going to make a line from the origin, just another little dotted line to help me here. Okay, so again, this is just from this green segment, this is 90 degrees. Now, what's the other thing that I need to figure out yet? I've got the angle correct, but don't I want to make sure that this point still stays the same length out? That segment should still be the same length it was when I started, right? So I got to make sure that I can measure their length. Oh, and you guys can't do that without rulers. Okay. Emergency ruler pass out. Who can help me really fast? Okay. Oh, you haven't done anything yet. Here you go. Okay, any event. So I'll show you with mine, but yeah, we need rulers. Sorry. We won't after this example because, like I said, there's a shortcut. You can go to a table and we should be fine. So, length of it here, I'm doing centimeters. Looks like I got somewhere in the neighborhood of 3.7. Okay. So I'm going to go out 3.7 centimeters on here, and that should be about where that segment would have ended up after I rotated at the end of it. So 3.7 puts me about right here. All right, so I did centimeters. Yeah, I measured it to be about 3.7 centimeters. So I measured 3.7 centimeters out on the new line there. And so that's going to put my B prime about here. Okay, so I've rotated that point, and now I got to just repeat that process for the point A and the point C. Okay, So I'll go to point A next. I'll make this one pink, I guess. All right, if you didn't catch exactly what I did there, just pay attention to this one, and then you can just repeat it for the last one. So I'm going to use this pink line now. I want to make a 90-degree angle again. So I'm going to take my protractor, put it on there, make sure the bottom of it is at the origin, swing this thing up. So that's right over that pink line. And then find my 90 degrees right here. Okay. So now I'm going to get a new dotted line coming up this way for that one. But again, I want to make sure that the length of that segment, the original pink segment I started with, it has to be the same length when I rotate it so that that point A is still the same distance away from the origin. So I'm going to go centimeters again here. Let's see what we got. Looks like I'm sitting at about 6.9, close to 7, almost 7. So if I come out on this new dotted line here, when I go almost 7, that's going to put me about right here. All right, so that's going to be my A prime. Bless you. Okay, shh, quiet please. Okay, so that's that segment rotated, and then I got to do the last one yet. Same process. So I'm going to go make this one blue. Question?
How did you get that full length of that, like on B? How did you get that full thing in pink, and then on B prime, you only got it halfway?
B prime goes with this one.
Oh, so you just measure how long that segment is there.
Right, I measured how long this was and then went the same distance out that way.
Right.
This one I measured how long this was and then went the same distance out that way. Yep. And I'm going to do that same thing here with C. Rotation first. So I'm going up the blue line this time. Alright, and then I find 90 degrees here. So I can connect that to the origin. That's my construction line for C. Alright, let's see how long that blue line is there. So that's in centimeters looking like about, I don't know, 4.6, 4.7, somewhere in there. So if I go about 4.6 or 7, I'm ending up about right here. So there's my C prime. So make that one blue. Okay, so I'm going to move this B prime to the other side here because it's going to get in the way of my triangle. But if I put these together now, I should have my triangle all rotated. Okay? Okay, so see if you can kind of visualize in your head this triangle making its journey here. Okay, it's rotating, okay? So like pretend like all of these lines